Tough, isn't it? Oh.
Hey guys, this is our first Hampshire Chemistry video. You just took the PSAT or the SAT. There's going to be a lot more of these next year. Make sure you subscribe. These guys will be there.
Yeah. What he said.
All right, we're going to do this in one take, so don't mind Mr. Ozarka. All right, guys. So today we're going to learn about dilutions. Dilutions are things that can make this red cherry Kool-Aid turn into this pink cherry Kool-Aid. They're both cherry Kool-Aids. This is concentrated. This is dilute. All right. There's a fancy equation that we're going to do a dilution. It's M1V1 equals M2V2. When we do these videos, make sure that when I am writing, you are writing. So you should all have this written on your paper. If you guys remember Boyle's Law, this looks kind of like a Boyle's Law problem. So you have your ones and twos. Ones are, we'll do ones for dilute or concentrate. We'll do ones for concentrated. I got my guys here.
Yep. We did not go away.
Twos will be for your dilute solution. So what this equation allows you to do, it allows you to calculate things like, oh, you know, how much water do I need to add to this red Kool-Aid to make it taste more like dirty water, like the pink colored Kool-Aid. It's very helpful. All right, so I mean, that's pretty much it. Remember, we were looking at concentrated solutions, what that would look like on a molecular scale versus a dilute from the other day. A concentrated solution would have a bunch of solute particles dissolved in it. A dilute solution would have less solute particles dissolved in it. And just remember, we are looking at aqueous solutions. Those are all things that are just dissolved in water. Mr. Security is going to go through a sample problem with you guys. They're all pretty much the same. Have fun. Oh boy. One take, guys. One take.
They can't hear your brother right now. Yep. There you go.
We're good. All right. Hello, everybody. So we're going to look at our first example up here, or at least the first problem. What is the final concentration of a sodium carbonate solution? The actual solution does not matter for these. So if you don't like writing out the formulas of something, hey, it doesn't matter. Good. So the final concentration for this solution, if you dilute 45 mils of this molarity solution to 350 total milliliters. Cool. So what Mr. Bowers just put up here, concentrated solution is M1V1, dilute solution is M2V2. So we're looking down here at our problem. All I'm going to do is write out my equation. M1V1 equals M2V2. Normally, what we do in advanced chem is we solve for what we're trying, or at least we basically do the math. All right, we're going to move our variables around. We need to solve for the final concentration. All right, so concentration, the unit that we used is molarity, so that's going to be our M, right up here, M2, because of final. All right, it's never going to say what is the M2. No, it's final concentration. We're using our words. Okay. So if we're trying to solve for M2, we are going to divide both sides by A2. And again, as Mr. Bauer said, as I'm writing, you are writing as well. This is our final equation. Cool. All right, so again, in the dilution process, all you're doing is adding water. So you're starting with 45 mils of this solution, and you're adding some water to it until the final volume is 350 total milliliters. You've all added water to stuff, okay? It dilutes it. So if your coffee's too strong, you add cream to it, it dilutes it a little bit. It's not as strong. Hooray. Yeah, so now we just plug our numbers in. Make sure your units are the same. So your volume here is in milliliters. That's the initial volume. So we've got V1 there. So for V1, that's going to be my 45. Final volume, it says 350 total milliliters. That's going to be V2. And it does say here you have 45 mils of a 2.5 molar solution. That's going to be M1. So let's plug it in. Again, as I'm writing, you're writing. So do 2.50 times 45 milliliters over 350 milliliters. All right. So again, we put units so that we know what cancels out. We see here, oh look, milliliters cancel out. Woohoo! You're left with molar, or moles per liter. Okay, so we should be good, because again, we're trying to find out final concentration. Molarity is a concentration. Okay. Times 45 divided by 350. All right, 0.32 molar. And does that make sense? The back of our homework, we have all our answers up there, and there we go, 0.32. Cool. So again, whenever you get an answer like on a quiz or test or something, don't just, I don't know, circle the answer and call it a day. Make sure it makes sense. So you are adding water to this to make it 350 total milliliters, so it has to be more dilute, and it is. If your answer is 3.2 molar, that makes no sense. That means you're adding water to something and it's getting more concentrated. Doesn't make any sense. Okay, so that's it. Cool.
Let me awkwardly come in here.